Two and a Half Admins, episode 87. I'm Joe.
I'm Alex.
And I'm Alan.
And here we are again without Jim, because he's still feeling a little under the weather. He's improving, but he's not 100% yet. So, Alex, you're joining us. Thank you very much. People may know you from the self-hosted podcast, selfhosted.show.
Thanks for having me.
Before we get started, Alan, your customary blog post plug is building your own FreeBSD-based NAS with ZFS.
Yeah, so if you want to build your own NAS and use just vanilla FreeBSD so that you can do other things with it, and rather than making it just an appliance-type NAS, then this guide will help you do that, as opposed to if you do something like TrueNAS or Sigma NAS or MediaVault or whatever, where it's going to be focused on being an appliance. It makes it harder to do your other workloads with it as well. So yeah, if you want to do vanilla FreeBSD, check out this article and it walks you through it.
Right, well, link in the show notes as usual. As you're joining us, Alex, I thought we should talk about Insteon. This is, or was, a smart home device manufacturer. And this weekend just gone, they basically just turned their servers off and bricked people's devices. And then the CEO just got rid of his LinkedIn page. They closed down their forums. They just went completely dark. It seems like you might have an answer for people who may be the victim of this.
As if we needed more fuel on the particular fire of Internet of Things, e-waste, garbage, software type things coming out. This is just so awful for so many reasons. It's literally like someone's gone out in the building, locked the door and turned the lights off and said, see you later, without actually communicating anything to their users. It's just a horrible, horrible way to do business. And so one of the things that makes Insteon so difficult in this situation is they had a proprietary networking protocol. So think of it like a Z-Wave or a Zigbee type thing, but proprietary. Luckily, it has been reverse engineered, so there is a silver lining there for some people. But you did, generally speaking, when you bought into Insteon as a company, require their proprietary hub. Now, I wrote for Ars Technica last year at some point why we all need an open standard and interoperability for smart home gear. The target of that article, the subject of that article, was obviously Home Assistant. I know there are other games in town like OpenHab and Domatich. I'm never quite sure how to say that one. But Home Assistant for me is something I've used in my house for 3 or 4 years at this point. I've given several talks on it. I've written, obviously, an article about it too. And we talk about it on the Self-Hosted podcast all the dang time. And this thing is just great because it doesn't really care which vendor a specific device is made by or works for. It speaks those several hundred different protocols, languages, whatever, speaks to cloud service for you. And you end up with a single pane of glass that can talk to all those devices on your behalf. And the best part is Home Assistant is free and open source software. So even if the company behind Home Assistant, the open source project, Nebukasa, goes away, we still got that code until the end of time because it's open source. And I just think that's fantastic.
And that is really the solution here for people who have been using the Insteon stuff.
So even if you bought into a certain ecosystem, a certain manufacturer, and you're going to buy their stuff, eventually they iterate their stuff and they're like, yeah, this stuff from before is not compatible anymore. And, you know, there's like forced obsolescence is like, yeah, this stuff is built into the walls of my house or whatever. You can't really force obsolete it quite the same. It's not an iPhone that I can easily just replace. And so having, like you said, an open standard and more open controller bits so that you can mix and match and you can just deal with the fact that you build out these components over time. You swap things out. You want to change things and you want to be able to survive the manufacturer going out of business. And like a lot of times, like I'd rather if all those parts of my house weren't calling out to some server in the cloud that's going to be down someday, even if it's only temporarily.
Well, with its servers down, Insteon required you to use an app. And that now obviously means the app doesn't work. The good news is, I suppose, that many of Insteon's wall switches were actually electrically part of the circuit, so they'll still continue to operate as dumb switches, just very expensive ones. And so for me, it really highlights the importance not only of open software, but also open hardware and firmware too. So, I mean, I'm a huge advocate of a project called Tasmotor, which you can put onto Shelly devices, Sonoff devices, tons and tons of these things. And Tasmotor is an open source firmware that will keep working on that physical device locally on my network until the device physically stops working. And at that point, I'll buy a new one. I'm cool with that. What I'm not cool with is when a company changes its business model or simply plans its business model around forced obsolescence in order for me to be forced into an upgrade that I don't physically need.
Yeah, although I'm just having flashbacks to reading the instructions on how to replace the firmware on some model of smart light bulb. Where it was like, turn it on for 10 seconds, then off for 5 seconds, then on for 10 seconds, then off and on again really quick. And then when it starts blinking, you know it's ready to now receive the firmware update.
True.
So you mean the whole time it's firmware updating, I have to deal with it blinking?
There are shops you can go to that sell devices like this pre-flashed with Tasmotor. In fact, if you look on AliExpress, even you can find these things nowadays as well. I would like to see open firmware become more of a standard. Maybe we need to influence people in governments to kind of mandate this vendor lock-in of hardware to be illegal somehow. But, there's a lot of money to be made in forced obsolescence, isn't there?
Well, and, it definitely gets right into that, right to repair type stuff.
Definitely.
We've seen that argument around, farm equipment and so on and electronic devices and all kinds of things. And, for some of the farm equipment and cars and stuff, they're like, well, people doing it themselves will be unsafe. It's like, yeah, it's a light bulb. How about it's my light bulb. I should be able to make it do whatever I want.
Well, what if it's not a light bulb? What if it's your garage door opener, for example, and then the security of your house is compromised? Or what if it's a camera and people can see things they shouldn't see? Or a thermostat, I don't know why. I don't know what's dangerous about a thermostat. Maybe they make my house too hot, something like that.
Or turn my furnace off and then my pipes freeze and now my house is flooded.
Yeah, you can do serious damage with a thermostat.
Spot the Canadian who's used to it being cold.
Yeah.
Well, you can blackmail people. Like remember when Texas had that big power outage and stuff. It's like, imagine that wasn't happening. They're just having a heat wave and be like, I'm going to turn your AC off. And, until you pay me some Bitcoin, I'm not going to turn it back on.
Good point. Yeah. And in a scenario like that, something like Home Assistant will keep working as long as you have, some kind of backup power of some description, because it's all local. It doesn't make any calls to the cloud unless you want it to.
Yeah, like short of, the thermostat's trying to do machine learning to decide when to adjust the thermostat, which I never want anyway. Most of the stuff I would prefer to have a guarantee that it's not talking to some random machine in the cloud. But it reminds me of these early smart lamp controllers. So basically, you plug it into the wall and then you plug the lamp into it. And it allowed you to turn the lamp on and off from your cell phone. But it turned out this worked by the app on your phone, calling a server in China. That was somehow the plug in the wall was calling the server in China all the time, being like, should I turn on? Should I turn on? Should I turn on? And then with your phone, it would turn on, or it had like a WebSocket or something. But it turned out that the server in China was doing this all based on the MAC address of the individual devices. So somebody reverse engineered the app, because it turns out it wasn't doing HTTPS. It was just doing raw HTTP. And just started going through the entire address space of the MAC addresses, because, you could see what the manufacturer was. So, the first couple of digits of the MAC address, and just walk through the rest of the range, just turning them on and off and on and off, and just make people's lights go crazy. It's like, yeah, it turns out that the people trying to make this device as cheap as possible are not going to have written very good software for it. Maybe it's going to look nice, but it's probably not going to be good in the back end. And then people are turning your lights on and off, or like you said, watching your camera. That one's been huge.
Follow the money, always.
There was quite an alarming aspect to this Insteon story, that if you did a factory reset of your hub, one of the last things that it did was talk to their servers, and so it was effectively bricking people's hubs. But thankfully, Home Assistant have updated their documentation now and seem to have got over that. So it's been very quick work by them, especially after the Easter weekend and stuff. So well done, Home Assistant.
I would love to see, and I know I mentioned governments and stuff before, but some kind of, I don't know, like fair play pledge or something from electronics manufacturers about how to sunset services and sunset gear. Fair enough, I guess, if you want to be proprietary for the 5-10 year life cycle of that product. But when it comes time to force people to upgrade or what have you, give me an option to put an open firmware on it. Give me the encryption key, whatever it is. I don't really pretend to know the details there, but make the devices open and just help us reduce unnecessary e-waste.
You're a dreamer, Alex.
Also, maybe put a note on the website and actually tell us that you're gone instead of just being like, yeah, the door's locked and the lights are out, but there's no sign that says gone out of business.
Let's do some feedback then. And Chicken sent us a link to a video called Harder Drive, Hard Drives We Don't Want or Need. And this is from Tom Murphy. Sucker Pinch is the YouTube channel. It is absolutely brilliant. He combines like really terrible but also amazing MS Paint style art with 3 examples of how to make a harder drive, just storing bits various silly ways that are just ridiculous. It's brilliant.
Yeah. So the first one he did was storing data in the internet. So with this one, basically, he'd make a virtual hard drive. He used FAT12, which was used for the 5.5-inch floppy disks. The file system has a maximum size of 51 kilobytes. So it's basically 100 512-byte sectors. And so each of those sectors is actually an ICMP ping with a size of 512 bytes, or a payload of 512 bytes, being sent to a number of different hosts. So once you write a sector, it's going to ping some number of hosts. I don't know how many. It was enough for redundancy. And then it doesn't remember the data. It just sent the ping out a bunch of times to a bunch of different hosts when you wrote it. And then when the reply comes in, it just turns around and sends it again. And so it's never storing the data on his computer. The data only exists in the pings going back and forth across the internet. And he specifically picks hosts that would have a high latency, so it would take more than 100 milliseconds. So you like ping Australia or something in a bunch of different places. And so he managed to store RFC 792 or whatever. The text document describes how pings on the internet works, is what he's storing in a series of pings going out to hosts across the internet. And they're only stored in the packets going back and forth across the internet. And that's why he was specifically looking for hosts that were very reliable, but had very high latency so that he wouldn't have to send the ping as many times in order to store the data.
I enjoyed particularly the animation style, the MS Paint thing. And at the beginning of the video, in particular, he was talking about how to juggle chainsaws by throwing them into orbit and saying like the maximum we can wield, like a Terra wield is the maximum unit that we can have of chainsaws. And then, oh, by the way, this is actually how a hard drive works.
Yeah. And then he went on to, there's a certain radio frequency just less than like 40 megahertz where it won't leave the atmosphere, and it could go all the way around the world and come back to us. And so we could store like 750 kilobytes of data by just sending it. And by the time we got it back and sent it again, it means in transit we could have like 700 and something kilobytes, which reminded me of like the sliding window in TCP. And it's like, hey, yeah, if he'd used TCP, he could have kept more data in flight. But that requires cooperation from the other side to send you the data back, where ICMP ping, that's already part of the protocol, is I send you a ping. So when you send a ping, normally it's like 32 bytes. And depending on your operating system, I think on Linux and BSD and so on, it's just like A to Z and then 0 to 9 or something to add up to 32 bytes of payload. On Windows, there's certain letters missing from the set of letters it sent. Like, I think it doesn't have a 1 or an L because those can be confused with each other, except for like nobody's meant to look at the packet like that. So I don't know why they skipped certain letters, but they did. But that can technically be larger up to the MTU of your network. So yeah, you could send like 1,400 bytes if you wanted to, but he did 512 byte pings and then one for each sector on this virtual hard drive. And I thought that was pretty amusing. And then he did a couple of other interesting ones, including using used COVID tests. Each one had a 512 byte EEPROM that had like the configuration for this thing on it. And he soldered them all together and basically made this thing that would hold it all, except for there was something wrong with his electrical outlet. The ground wasn't working properly, and he zorched his Raspberry Pi and couldn't get a replacement in time. So he never actually got to see how fast it would be.
Yeah, I think there was 2 Pis that he managed to do it with before he realized that it was the outlet that was bad.
Yeah.
Not a good time to be frying pies.
No.
Well, the final one was Tetris.
Using like 6,000 NES emulators at 1.6 megs of RAM each. So it turns out the random number generator in the original Nintendo version of Tetris was based on a shift register or whatever. And so if you wait, is based on your input. So if you wait to move the block a certain amount of time and then press the button, you influence the random number generator and you can pick which block you want to come next based on how many frames you allow to happen between when you press the buttons. And so we wrote a thing that would be able to like store a certain byte value in the Tetris thing. And it would like decide how long to wait for each block and eventually encode this binary 1 byte in each Tetris field.
But of course, it can't be all zeros or all ones, because as we all know in Tetris, that would be get rid of a line of data, and nobody wants that.
Yeah, so at first I was thinking, well, there's like that 10-bit encoding, so you'd have parity and everything, but he decided to just use the leftmost 2 columns as control blocks and to make sure that he wouldn't have all ones or all zeros.
It's probably worth mentioning that none of these methods are particularly reliable methods of storing data, are they?
Well, so the ping one had the definite problems, like if your machine reboots or something, or the host on the other end just decides it's annoyed with you for sending so many large pings, then data can get lost.
I enjoyed that one in particular because he mentioned in order for the ping round trip time, it was about 100 milliseconds or so. In order not to miss the reply, you'd have to reboot your system in 100 milliseconds or less.
Yeah. The Tetris one was reliable if you could keep your machine from rebooting. So, you have battery backup or whatever, you're probably not going to lose data. It's stored in the memory of the program, and it's okay for, uptime anyway.
Something ButterFS.
Yeah. But the Tetris emulator one was pretty interesting, especially getting into how the random number generator worked and specifically dealing with the problem. So the random number generator in vanilla Tetris had special rules in it. Basically, it was rolling a 7 or 8-sided die to decide which piece to give you. But if it was the same piece as last time, it would roll the dice again to reduce the likelihood of getting the same block twice in a row. So it was still possible to get the same block twice in a row, but you'd have to roll the same dice 3 times, not just twice. So if you had a double, it basically would re-roll and to try to reduce the frequency of that. And some things like that. And it meant to the point where he literally had to teach it to pause the game and wait and unpause it in order to get the timing right to make sure he got the piece he needed. And then lastly, he did theoretically, using the Bitcoin blockchain to store data, and found that comparing byte watts or whatever, that, Bitcoin was the least efficient way of doing anything.
That was the punchline, essentially, wasn't it?
Yeah.
Okay, this episode is sponsored by Linode. Go to linode.com/25A to get started with $100 free credit. From their award-winning support offered 24/7 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and more. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. Okay, Stefan writes to us, I listened to several podcasts and the cost of backup is a common theme, but none of you are considering Yotta at yottacloud.com. It's a Norwegian company under strict GDPR. The personal account sets you back approximately $70 to $80 a year, but you have unlimited storage, Windows and phone apps, and a Linux API. Currently, I have 2.6 terabytes in the cloud. I personally use SyncThing on my computers to my main server. That server syncs to Yotta. I found this the best option for me. I'm not affiliated with them, I just use them. Unlimited. I don't like the sound of that, chaps.
Yeah, so I'm looking at their stuff, and some of the pricing is a bit confusing. So yeah, they have their personal plan, which is about €8 a month. It says unlimited storage space, 1 user account, although it does say upload speed will be reduced if your storage exceeds 5 terabytes.
They do actually have an article on their website if you're curious as to what the reduction in speeds are, and roughly every terabyte or so they'll start throttling you pretty heavily, to the point where when you've got more than sort of 10 or 12 terabytes up there, you're going to really struggle to upload anything meaningful to that service after that point. So they're kind of saying we're unlimited, but you actually can't do more than 10 or 12 terabytes with us.
Well, they have the Yotta Cloud home subscriptions where they actually, you can buy 5 real terabytes of storage with no bandwidth limitation. It's just €13.50 a month. I'm like, okay, that sounds a little more reasonable. You're actually giving me a quota and charging me a price for it. But then I'm comparing to the plan beside it, which is 10 terabytes for the same number of users. It looks like all exactly the same features, but twice as much storage. but it's 50 euros a month. Why does that seem to scale the wrong way around?
I agree. The pricing just doesn't give me the warm fuzzies. And when you actually look at their privacy policy as well, there's another concern that I have. So Yotta Cloud don't provide an end-to-end encrypted service, which means that they have the keys to decrypt your data at some point if somebody makes a GDPR request from law enforcement or whatever. The rationale that they seem to give through the research I did was to prevent people uploading pirated content to their servers. Obviously, though, if you're putting your personal data up there, who's to say that someone at Yotta doesn't decide to look at it? I'm not accusing anybody or anything, but it could technically happen, right? So it's much like Dropbox in that situation where, it's not fully end-to-end encrypted.
Well, especially the end-to-end question comes up, like how encrypted is just in transit. Like, I guess maybe it's HTTPS or something, but yeah, it does. The fact that they're going to have it at multiple steps in that is a little concerning. And then going to their pricing page, I see they have separate business plans. And if you're a small business, it's 11 euros, and a medium business is 16 euros, and a large business is 40 euros, all for the same 1 terabyte. It's just how many users you get, which seems a bit odd.
Why is users the limiting factor? Like,
yeah.
An extra seat doesn't actually cost you any money, but extra disk space does.
Okay, it's an extra 8 euros a month per terabyte for extra storage.
So all of this had me thinking about, why would anybody pay for a cloud service for a company that isn't super well known? They're not an Amazon, for example. They're not a Google, with Glacier or whatever Google Drive is doing this week. And for me, I solved this problem by putting a couple of servers in family members' houses. I've got one in the north of England and one in the south of England. So I have 2 systems. One's a Synology box and one's just a Linux box running ZFS. So I do ZFS send to one of them using Jim's Sanoid and Syncoid toolset. And the other one, I use Restic, which I wrap with AutoRestic, pushing it to an S3 Minio container that's running on top of Synology. And so I have 2 completely separate backup systems there, which, if my fat-fingered Ansible automation kind of screws up one of the backup systems, for some reason it stops working, chances are I'll catch that before the other one stops working as well through the monitoring that I have. And if I look at the cost of these things, Yotta Cloud is $100 a year, give or take. And at my family members' houses, I have 20 or 30 terabytes. And if I wanted to put that kind of size of data set in the cloud, it's just prohibitively expensive to do so. And with Yotta particularly, the performance just wouldn't be there. So you've got to look at, not only the cost of buying the server up front, which is going to be more than $100 a year. It's going to take several years to ROI on that. But obviously nowadays, of course, the price of electricity is going up, as I'm sure you're acutely aware, Joe.
Yeah, there's a lot to consider, but I don't think that Yotta is quite the silver bullet that Stefan thinks it might be. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support for more details there. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions, normally for Jim and Alan, or your feedback or topic suggestions or anything else, show@2.5admins.com is the email.
Or compliment the fact there are 2 British accents on the show this week. You could do that too if you like.
If you really, really want to, yeah. Another perk of being a patron is you get to skip the queue, which is what Al has done. My question is about ZFS and multipath. In cases where there are several controllers and SAS adapters, every disk is visible multiple times, and we usually configure multipath for reliability and redundancy. Does ZFS come with such a tool, or is multipath still needed along with ZFS? In my case, we have a Dell EMC ME484 JBOD with 2 controllers hosting 72 disks, which is directly connected to a Dell R740 XD. How would you configure this machine with ZFS?
So yeah, ZFS doesn't do anything magical for you, so you'd have to set up multipath. If you're on FreeBSD, there's a geom class called multipath, so the command is gmultipath. On Linux, you would use something like dm-multipath. And basically, this will make a new device under /dev somewhere that combines the multiple paths for the same device into a single device. So on FreeBSD, you'd have dev/multipath/ whatever you call it, and that will be, DA0 and DA73, which are the 2 disks with the same serial number, as a single device. And the GM class will take care of, the first controller went down, we'll route everything over the second one. Or you can tell it whether you want, active-active or active-passive or active-write and so on. And it will route the read and write requests to the multiple controllers that way. And then you make the ZFS pool out of those multipath devices. So the way I normally do it is I label the disks with a multipath name of a letter, usually identifying if it's the front or the back, because some of my JBODs are dual-sided, and then the slot number, dash, and the serial number of the disk. I find it makes it much easier to deal with replacements and so on if I have all that encoded right in the device name. But yeah, create the multipath setup as you would for any file system, and then put ZFS on top of that.
Okay, Logan writes, in my home lab, I run a few Docker containers that require a database, Postgres. This Postgres database is on a separate VM host from the Docker containers. It gives me one central place to manage my databases. Would you recommend instead putting a separate Postgres Docker container in the same stack as each Docker application? I would store the database info in Docker managed volumes. This would give me 3 separate Postgres containers and also eliminate database traffic going over my network and even possibly speed up my applications.
Well, for me, yes, I would. I've been a proponent of running one container per application or 1 DB per application for probably a couple of years now. Thing is, I used to be the other way. I used to have one MySQL container that ran 5 or 6 other containers worth of stuff. I had a couple of Nextcloud, for example. I had a couple of other things, like a Git-T, I think, pushing into that MySQL database. And one of those apps on an upgrade did something, and I'm going to say I'm not a DBA. I can understand SQL queries. I can select. I can do all that kind of, regurgitation of old computer science stuff I did a long time ago about merges and unions and joins and all that kind of boring stuff. But to be honest with you, if I can make it simpler to recover from a failure by doing something simple with a minimal overhead, like running one extra Postgres container, I would be inclined to do that.
Yeah, there's kind of pros and cons both ways here. Being inside the same machine will reduce the latency. Now, the latency over your network is going to be less than a millisecond inside the same LAN, most likely. But if you get up to a really high number of transactions per second, it can start to actually have an impact there. A couple of reasons why you might still have it as a separate host or something is hardware. Like if my Docker compute container that's running all these applications is all based on hard drives, and I have another machine that's all SSDs, I'm going to want the database on the SSDs to get that more performance. So that's one reason why you might do it the other way. But in general, having a bunch of separate containers is probably better. There's one caveat for that, depending on how much memory you have in cache and so on. If you have 4 separate Postgres databases and each running as a VM or whatever with 2 or 4 gigs of RAM or whatever, then that's the most amount of cache that Postgres can have. If you do it all as one bigger VM, while it may be the same amount of RAM, if one of those databases isn't using all that RAM for cache, then the other one can have more than it would if it was a separate database. But at the same time, if your applications are competing, you might not want them to be able to share like that. So that kind of relates to what we were talking a bit about last episode of if the VMs are competing with each other, if they're hosting stuff for other people or something, then you might want them all separate because you don't want one busy one to disadvantage the other database. But if they're all yours, you might actually want the more busy one to be able to basically steal resources from the less busy one.
I also find a lot of value in one of the compose flags that you can set, which is depends on. So I can say this Postgres container depends on Git-T, and I can specify a specific instance of Git-T or drone or miniflux or whatever it might be. And that way I can guarantee that the database is up and ready first before the actual application tries to start, because otherwise you might end up in some kind of a race condition where the application is trying to say, hey, database, are you there? And it can cause problems.
Most likely putting it on the same machine is definitely a win, and doing a separate container for each application does have some advantages, but depending on if you have the resources, sometimes there's a slight advantage to bundling them together just because they can share. You can make use of the Slack from one app for another app that way.
Right, well, we better get out of here then. Thank you very much for joining us, Alex. You've filled Jim's shoes admirably, much like Dalton did last week.
I must say, I feel very humbled to be in good company with you and Alan. So thank you for having me.
Yes, thanks for being here.
You can find me on Twitter at Joe Ressington.
I'm over there at Ironic Badger.
And I'm at Alan Jude.
We'll see you next week.